At the beginning of the section, we discussed standard form for a quadratic function, and we said that that would be f at x equals ax squared plus bx plus c. In this particular section, we're going to talk about vertex form. A quadratic that is written in the form y equals a multiplied by the quantity x minus h squared plus k is said to be in vertex form. In this particular form, we can read off the vertex, and the vertex would be h comma k. We also can read off the symmetry when we have a quadratic written in this form, and we can read off where our symmetry line is, and we can call it x equals h, just as we did when we were talking about the axis of symmetry in one of the earlier examples. Remember, it is important to use x equals in your answer. You will not receive full credit if you just give the h. It is a line, and we need to write it in the form of a line. Notice also the parabola will open up if a is greater than 0, and it will open down if a is less than 0. So if a is greater than 0, our parabola has this general shape, and if a is less than 0, it will have this general shape. Let's take a look at a couple of examples. Suppose we're given f at x equals 4 multiplied by x minus 1 squared plus 7. In this form, we can read off the vertex. The vertex is 1, comma 7. Notice this falls directly in the form that I gave you as the general equation. We have x minus, and so the number that follows the minus gives us the x-coordinate of the vertex, so it's 1. And then plus k, we have plus 7, and so the y-coordinate of our vertex would be 7. The axis of symmetry is the vertical line that passes through the vertex, and so in this case, that vertical line would be x equals 1. I could actually draw a fairly decent graph of this particular function without ever pulling out my calculator. I know the vertex is 1, 7, so I can go to 1, 7. And I know that my leading coefficient is positive, so I know my graph opens up. And if I wanted to, I could actually find the y-intercept by making x be 0. And if I did that, if I made x be 0, I would find out that my y-intercept is at 11. And so I actually would know I have the point 0, 11. And by symmetry, I would actually have to have the point 2, 11. Let's take a look at our second example. Suppose we're given f at x is the negative of the quantity x plus 5 squared minus 1. Now if I want to get the vertex, you'll notice this is not written in the form x minus a number. It's written as x plus. And so we would have to think of this as x minus a negative 5. And so therefore, the x-coordinate of our vertex is negative 5. Again, notice it's not written plus k. It's written as minus a number. And so we would think of that as adding a negative 1. And so therefore, the y-coordinate of our vertex is negative 1. Again, we could get our axis of symmetry, which remember is x equals the x-coordinate of the vertex. And so in this case, that would be x equals negative 5. Again, I could get a reasonably decent graph of the function. I know my vertex is at negative 5, negative 1. I notice that my leading coefficient, that the number in front of the parentheses, would be a negative 1. And in fact, it's negative, so that tells me my parabola, my quadratic, opens down. And if I wanted to, I could again substitute in 0 for x to get the y-intercept. If I did that, I'm going to get negative 26. And so the graph I've drawn, we won't really see where that's located. I would need to expand the window that I drew on in order to be able to actually see that particular y-intercept.